limit x goes to 0, cosine to the 4th x over 5 plus 2x cubed. So there's going to be a few properties I'm going to use here. First of all, I have a fraction, don't I? I have a fraction. So there's something in here in the notes that says what you can do with fractions. It's 1.4.2, number 5. Says that I can split this into two limits, right? One limit on top, one limit on the bottom. So technically what I'm doing is this now. Limit x approaches 0 of the top, the numerator, divided by limit x approaches 0 of 5 plus 2x cubed. Now you don't need to write all this detail like I'm doing, splitting it up. At the end of the day, it's just going to be plugging in, but I want you to see where these rules are being used, all right? Now, let's look at the numerator. I have a power, don't I? That's the last thing happening, a power. Which of the rules here tells you how to deal with powers? 6, property 6, or number 6. And so I could move that limit inside to the cosine. And how do you deal with cosines? Well, direct substitution property says as long as you have a polynomial, rational function, trig function, exponential, or log, you just plug in. So I'm going to move the limit in the power, and I guess I'll write it down for this example. I'm going to say limit x approaches 0 of cosine x, but then that's all to the 4th, all over. Now the bottom is a polynomial, isn't it? So I'll deal with that in a second. And now all I have to do is figure out what happens, or what is cosine of 0. What's cosine of 0, everyone? 1. What's 1 to the 4th power? 1. Over. Now on the bottom, what happens if you do direct substitution and just replace your x with 0 here? You just get 5. So notice again, my limits are no longer there. I'm not writing limit anymore. It's 1/5. There's no like voodoo magic happening here, right? I mean, this is pretty much, we're just plugging a value into the function and getting an answer. And if that's what calculus was, then calculus wouldn't be that hard. That's why there's still numbers, 12 through 28, right? So these were just to get us used to plugging in. Let's go to number 12. So this is where things start getting a little bit weird. Well, yeah, let's do 12. Limit x approaches what? 4 of x squared minus 4x over x squared minus 3x minus 4. So what is it I said a few minutes ago? What's the first thing you should do with limits? Just plug in and see what's happening. Right? I can get on this the fact that I've got a rational function, right? This is rational. Rational functions you can just evaluate, just direct substitute. So that's what I'm doing. So watch, I'm not going to do an equals. I'm going to do an arrow, because the arrow to me is going to mean this is what's happening as I try and plug in. All right? Let me see what happens. And I'm not going to write the limit anymore because I'm actually plugging in. So I get top right or top left corner, 4 squared is 16, minus what's 4 times 4? 16 over 4 squared is 16, minus 3 times 4 is 12, minus 4. Is that correct? So what do you get? 0 on top divided by 0 on the bottom. And you are not allowed to divide by 0, are you? So that means that the function is what at 0? Like if I looked at this thing in here as a function, call it f of x, then I'm trying to figure out what f of 4 is, and f of 4 is turning out to be what? 0 over 0, which is undefined. Now, what does that tell me about the limit? Nothing. It tells me nothing, okay? All I know is that if I try, remember, calculus is about trying to figure out, the limit is about trying to figure out what's happening as we get close to, right? I tried to sneak around by just trying to figure out what happens at 4. When I did that, it was undefined. So I don't know what's happening near it. I only know what's happening at it, and it's no good. So I've answered nothing yet. So I think I have a picture here for you. This is number 12. This is the graph of that rational function, okay? Now, normally you won't have the graph, but I just want to try and illustrate what's happening here. If you type this into your graphing calculator, you go to Wolfram Alpha, or you get some graphing utility, and you graph it, this is what you'll get, okay? What's happening at 4? If you look at that, go out to the x value of 4, and look up, the graph doesn't show an open hole there, does it? Like, it should show a little circle there, shouldn't it? But the computers don't show circles. So you would look at this and think that that graph is nice and smooth, when in fact there's a little jump over a hole that you can't tell. Am I making sense? But if I said, come in there, I'm going to copy this real quick. I'm going to paste it into this. Way too big. Okay. What's happening here is that at 4, what I've determined is that there is a hole, right? There's a hole there. But from the left side, am I headed somewhere? Does that come in from the left? Am I headed towards a y value? Yes, right? Something. It looks like it's getting close to 1. It's kind of hard to tell from the graph, but it looks like the height is about 1, maybe. I don't know. Pardon me? It looks like it. But from the right, it's also approaching the same thing, right? So it appears that the limit does exist. But I can't tell by trying the direct substitution. So how are we going to get around that and get to an answer, right? Do y'all understand what I've done here, right? We are not finished at this point. We're not finished. All we can say from this is, crap, I don't know anything. So here's what we'll have to do. After trying to plug in and getting 0 over 0, what that tells me is that you're going to try to do some algebra or some sort of trick, because Calculus 1 is a lot of tricks, all right? I need to do some algebra or a trick to this, and I'll even put that underneath that question mark. I need some algebra here or some sort of trick to figure this out. So I'm going to rewrite the rational function, but I'm going to realize that that numerator factors, doesn't it? Didn't that numerator factor? I can pull a GCF out, right? We had x squared minus 4x. I can pull an x out of there. And then on the bottom, we have a trinomial that also factors. And it would factor to be what? X minus 4 times x plus 1. Now, if you're going to struggle with that part of it, I'm going to tell you need to get your factoring in order ASAP, because that's something that's just an assumed skill at this point. So what do I have in common in the numerator and denominator? The x minus 4s. So because I have a common factor, I can cancel them. Now, the only reason that I still maintain the integrity of the problem is because I know that there's a problem when x is 4, right? And by canceling those out, it kind of makes you think that you're no longer going to have a problem. The fact that I'm using a limit here and that I'm saying what's happening as I get close to 4 is what allows me to do the canceling. It's because in a limit, x is never 4, it's getting close to it. So watch what my next line looks like. Equals, still have the limit, x approaches 4. What was left on the top? X on the bottom, x plus 1. Now you have a new rational function. Let x now go to 4. In other words, do direct substitution. And you get what? 4/5. And I'm no longer writing the limit because I've actually done the substitution. So we've determined that this picture, that it looked like it was 1, was actually 4/5. That's where it was headed to from the left and the right. What do you think? That's a good question. But what happens, and it'll happen in this class, it's pretty natural for a calculus student to get kind of in the mindset that, look, every limit that I ever see, I'm going to have to do algebra on. So you start doing algebra on it, and then you realize that you could have done direct substitution in the very beginning, and there was never a division by 0. See, if you do direct substitution, you get a nice number, you're done. So I would hate for you to be taking a test and trying to do all this algebra on something where all you had to do was direct substitute to begin with. So the first step should always be direct substitute. If you get 0 over 0, then you proceed on with algebra. Nope, we're going to get a bunch of different types of things that could happen. But our main concern is division by 0 is not allowed in our number system, right? We just can't divide by 0. All right, let's look at 14. 14 is the same exact function, but we're not approaching 4, we're approaching -1 instead. So the first thing I'll do is to try a direct substitution. So I'm going to draw an arrow to let everyone know, look, I'm just going to try plugging in right now and see what I get. So what do I get when I plug in -1 for x? On the top, -1 squared is 1. And then minus 4 times -1, isn't that plus 4? Okay. Over, -1 squared is 1. Negative and negative is positive, plus 3, but then minus 4. So what do I get here? 5 over 0. 5 over 0 is still undefined, isn't it? And so this is going to cause a problem also. I'm going to write down here undefined. Now, this is where I stray away from the book a little bit, all right? The book decides that they're going to talk about this situation later. And they say, for right now, we're going to put DNE, does not exist. And the reason, that's not what I'm going to do, but that's what the book says. And the reason why the book says that is because, look at this graph. This is the same graph, right? But where are we approaching? -1. So -1 is here, right? I'll put a little dot here. Here's -1. And does everyone see the asymptote here? Does everyone see that? So on the right-hand side, the one we did previously at 4, it looked like we were coming into the same place from the left and the right, correct? And we got 4/5. But on this one, what's the limit from the left? Positive infinity. What's the limit from the right? Negative infinity, right? So the book says to you at this point, anytime you get a fixed number that's not 0 divided by 0, that it does not exist. That's what the book says. I'm not happy with that because in 2 sections we're going to tell you something different. So I want to attack this now. Let's try and figure out what's happening now. Now, what should it be? Does anyone know what this limit should be going off the graph? It should be does not exist. Because from one side it's infinity, the other side it's not. I mean negative infinity. So positive infinity and negative infinity are not the same place. They're not headed to the same place. But how are we going to determine that from this answer? And this is where things can get a little tricky, all right? You all ready? Ask questions if you have any. So the key to this right now is that we have a fixed number that's not 0 over 0, as opposed to the previous problem where we had what over what? We had 0 over 0. Where is that one? Did I erase it? Oh, there it is, 0 over 0. Okay. So we had this. We were able to get an answer. But when we get a fixed number that's not 0, what do I mean by fixed? Like a constant, right? Like 5 or 10 or pi or